My dear friends, previous 4 classes we have discussed a lot of things about the electric charges, Coulomb's law, its properties, etc. etc. Today we are going to discuss about the electric field, the second part of the first chapter. What do you mean by electric field? Whenever we are going to discuss about the Coulomb's law, a body or a charged body get attracted by another charged body. It means two charged particles either attract or repel each other by a Coulombic electrostatic force. Let us imagine this is Q1 and this is Q2. They attract each other or they repel each other. Now the question arises. At which distance they will attract each other or repel each other? What is the minimum distance at which the electrostatic force between the two charges will be influenced? Or, in brief, the region in which two charges are placed so that the two charges get attracted or repelled by each other. That hypothetical imagination part or the region is called electric field. Let us imagine I have taken a charge Q and this is the modified space around it. It is a hypothetical, completely hypothetical concept. So in this region, if we place a charge, let us imagine I have placed a charge Q0 in it, then they attract. If I will place a charge Q0, then they attract. But if I will put a charge Q0, they will not attract each other. It is beyond that region. Beyond that region. It means the region in which its electrostatic force is influenced. The region, the hypothetical concept, is called electric field. Clear? So how we term it? Electric field means the modified space around a charge in which its electrostatic force is influenced is called electric field of that charge at that point. It is purely temporary. Purely imagination. It is represented by a set of imaginary lines. Known as electric field lines. Now the questions. The modified space, if you put a charge, the region, later on we will discuss that the modified space, the imaginary surface in which it's a force is influenced, that imaginary surface is later on we will discuss as a Gaussian surface because it is invented by the scientist Gauss. So I would like to say that when the charge is placed at center, there is a hypothetical imaginary surface, okay, and if we place a charge at the center of the sphere, then the surface of the sphere will be treated as it's a surface. Will be, or the region inside the sphere, the electric field is experienced up to its surface. And if we move away, its electric field gradually decreases. It means more effective in which region? That region is called electric field. Clear? Now, it is purely imagination and it is represented by a set of imaginary lines known as electric field. Now the question arises, sir, if that electric field is stronger or if that electric field is weaker, if that electric field is effective, then how much? Then how much? How it is measured? Keମିତି ମାପିବେ? That is called electric field strength. Or it is also called electric field intensity. Let us imagine I have placed a charge Q at the any point. Let an hypothetical imaginary surface, a spherical surface of radius R is assumed. Here Q be the test charge. Q be the source charge. And the charge placed at its surface Q0 test charge. R is radius of hypothetical surface. Listen carefully. Last class we have discussed about the source charge. Source charge means which has its own electric field. That electric field cannot be neglected. Well, test charge, it has also its electric field. Both source charge and test charge both have electric field. But here the magnitude of charge is large, so its electric field cannot be neglected. But test charge is very small, so it can be neglected. So I have taken test charge as a small charge whose magnitude is very small, while source charge is a large charge. It means its magnitude is high. Clear? So I place the Q source charge at center and its imaginary Gaussian surface, or you can say the imaginary surface of radius R, and on the surface Q0 with the test charge. Now, if it is so, then the electrostatic force F is 1 by 4 pi epsilon Q0 by R square according to Coulomb's law of electrostatic. Clear? Now, but what is electric field intensity? Electric field intensity E is limit Q0 tends to 0 F by Q0, or it is often written as F by Q0. It means if Q0 is very small, so just to test is it the force is effective or not. So just to verify it, we are assuming a small test charge, and that test charge is whose magnitude is very small. So I have assumed Q0 tends to 0 F by Q0. If it is so, the electrostatic force is 1 by 4 pi epsilon Q0 by R square by Q0. Okay, did you get it? If it is so, then electric field is 1 by 4 pi epsilon Q by R square. So we have already discussed what is electric field and the strength of electric field or electric field strength due to a point charge. So I have taken a small point charge whose magnitude is a large, source charge whose magnitude is small, test charge. Just to verify the electric field of source charge, I have assumed a small test charge Q0, and at last we conclude that the electric field directly proportional to the magnitude of the source charge. And electric field inversely proportional to distance of the observation point, at which distance the test charge is placed. Is directly proportional to the magnitude of the test charge. That's why the equation is straight line. Here it is inversely proportional to the square. It is also obey inverse square law. So E proportional to R square. So electric field and R graph is a hyperbola. Unit of electric field. As electric field is equal to force by test charge. So force, the unit of force is Newton and charge, so it can be written as a Newton per Coulomb or N by C. Dimension of electric field. Dimension, this is force, this is charge, so E is equal to F by Q0. I can write it because the dimension deal with qualitative part only. So the dimension of force is mLT minus 2, charge is a derived quantity, first class we have discussed, mLT minus, so mL T minus 3, A minus 1. Note, electric field, force is a vector quantity, so electric field is also vector quantity. Electric field of a charge is a vector quantity. Vector quantity means it must have its own direction. It means it is directed from, it is directed from positive to negative. Clear? It obeys the principle of superposition. Principle of superposition that we have discussed in the fourth class of electric charge. It means for a system of charge of any distribution, the net electric field experienced by a charge is equal to the vector sum of individual forces acting in it. Or I can find it that E1 factor is equal to, or E vector is equal to E1 vector, E2 vector, dot dot dot, En vector. If the body consists of n number of charge particles, then E1, E2, dot dot dot, En vector. Clear? The regular questions which is already asked in the previous exam, that does a charge always moves along the direction of electric field? Answer: may or may not be. Because we know that electric field intensity E is equal to F by Q0. It means F is equal to Q0 into E, or I can write it as a F vector is equal to Q0 into E vector. If Q0 greater than 0, that is for positive charge, F vector is equal to Q0 E vector, implies F vector is parallel to E vector. It means if the charge is positive, then charge will move. The charge will move along the direction of electric field. Q is less than 0 means for negative charge, F vector is equal to minus Q0, because Q0 is negative. A vector opposite to E vector. Clear? Some questions are there. Does electric field intensity due to a point charge is symmetric? According to coordinate system. It means electric field is symmetric. Symmetric means it is equally distributed along x-axis or similarly propagated along x-axis, y-axis, z-axis. How it is? Let us imagine. This is a Cartesian coordinate system. This is x-axis, this is y-axis, and this is z-axis. Let the source charge is placed at origin. This is source charge. Okay. And the test charge is placed here. Let it will be Q0. The charge and the coordinate will be x, y, and the z. The x coordinate will be along x-axis, the y coordinate will be along y-axis, and the z coordinate will be along the z-axis. So let it will be the r vector. If it is the r vector, then I can write r vector is equal to x vector, y vector plus z vector. Or I can write it as a x I cap, y j cap, and z k cap. Okay? In the vector form. And the magnitude of r vector will be x square, y square, z square, two term. As we know, electric field intensity E is equal to 1 by 4 pi epsilon 0 Q by R square, because it obeys inverse square law. I would like to say that in vector form, if you write it in vector form, 1 by 4 pi epsilon 0 Q by R cube into R vector, because whenever we are going to put the vector, I can write it as a R cap. Instead of R cap, I can write R cap is equal to R vector by R vector mode. So using this, the formula is equal to 1 by 4 pi epsilon 0 Q. R means x square, y square, z square. This is Q and this is half. So x square plus y square plus z square by 3 by 2 into x I cap, y j cap, z k cap. Even instead of E vector, if I will write Ex I cap, Ey j cap, Ez k cap. then Ex, Ey, Ez are the x, y, z component of electric field. It means along the x-axis there is a component Ex vector, Ey vector, and there is Ez vector. This is the three component of the electric field. So I can put Ex is equals to 1 by 4 pi epsilon 0 q by x square, y square, z square power 3 by 2 into x. Okay? Or I can write it as a Ex vector into x ik. Similarly, I can write Ey is equal to 1 by 4 pi epsilon 0 q by x square plus y square plus z square into yjk. Similarly, I can write zk also. It means along x-axis the x component, along y-axis y component, and along z-axis the z component will be act. Hence, electric field will be symmetry along the coordinate system. Clear? So, at first we will discuss electric field intensity, then how the electric charge will move. That depends upon the magnitude of the charge. Is it positive or negative? Then we will discuss the electric field is already discussed that electric field is also symmetric. This is very important questions while measuring electric field intensity of a charge Y. Test charge is assumed to be small. While measuring electric field intensity of a charge, Y test charge is assumed to be small. Y test charge is very small. I would like to say that let test charge is large. Test charge is large in magnitude. If the charge is large, it must have its own electric field. Then it must have its own electric field. We know that according to vector addition law, if there is two vectors are there, then the resultant vector is either their addition or subtraction or in between that. It means the source, the magnitude of the electric field of the sources get affected according to the principle of superposition. It may have its own electric field and that may affect magnitude, position of source charge due to the principle of superposition. Because if the test charge is parallel to the electric field of the test charge is parallel to the electric field of source charge, then it may increase. If it is opposite to the electric field of source charge, then it may opposite to it. It means there is a variation of net electric field. So if we neglect the electric field of a test charge is very small, then we must neglect or we can neglect the electric field of a test charge. Hence, and that does not affect the position or the magnitude of the source charge of electric field. That's why test charge is neglected. Clear? Let source charge is large in magnitude, then it must have its own electric field. Clear? That may affect the magnitude or position of the source charge electric field. due to principle of superposition. Clear? Now question. How can you explain the dielectric constant? How can you explain the dielectric constant with respect to electric field? Define dielectric constant. With respect to electric field. Listen to me. As like this force, we can take electric field in medium. Force in medium by charge or test charge if you take it. Then it is found to be 1 by 4 pi epsilon q by r square, or I can write it as a 4 pi epsilon 0 into k q by r square. Clear? Similarly, if you take EA or electric field in A, then force in A by charge, it is found to be 1 by 4 pi epsilon 0, because for air medium K is equal to 1 by 4 pi epsilon 0 q by r square. Hence if you divide this, let it will be equation 1 and this will be equation 2. Dividing equation 2 by 1, we will get it as EA by E medium equal to K. This is analogous to force in A by force in medium. It means whenever the dielectric constant goes on increasing, whenever the dielectric constant value goes on increasing, the electric field or the electrostatic force goes on decreasing. Clear? Calculate the electric field intensity due to a point charge (1 Coulomb) in air at a distance of 1 meter. My dear students, it is asked for the electric field intensity, so I can write it as a E is how much? Due to a point charge, so Q is given as 1 Coulomb in air at a distance of 1 meter and R is 1 meter. So according to formula, E is equal to 1 by 4 pi epsilon 0 Q by R square. Instead of 1 by 4 pi epsilon 0, I can write 9 into 10 to the power 9. And Q is given 1. So 9 into 10 to the power 9 Newton per Coulomb. This is the electric field intensity. Okay? A 2 nanocoulomb charge, I hope it is 2014, a 2 nanocoulomb charge is placed at a distance R meter apart, so that electric field intensity is 2 Newton per Coulomb. Then find R. Very easy questions. Charge is given, medium is given, and we are asking for R. So electric field in A is given as a 2 Newton per coulomb. Charge is given 2 nanocoulomb. 2 nanocoulomb means 2 into 10 to the power minus 9 coulomb. And asking for, so if we do this, E is equal to 1 by 4 pi epsilon 0 Q by R square. Clear? 1 by 4 pi epsilon 0 means 9 into 10 to the power 9. Q is 2 into 10 to the power minus 9 by R square. So 10 to the power plus 9, 10 to the power minus 9 cancel each other. So E is given 2 Newton per coulomb. 2 is equal to 18 by R square. Or R is equal to 2 1 jar 2 9 jar. R is equal to 9 root plus or minus 3, or R is equal to plus 3 meter. Two nanocoulomb charge is placed at a distance R meter apart so that the electric field intensity 2 Newton. Find the R. Listen here, nothing is mentioned means you can take it as a 2 nanocoulomb is the charge and a 2 Newton per coulomb is the electric field. So E, Q is given. There are three variables are there. E is mentioned, Q is mentioned, R is asking for. So easily calculated as 3 meter. Clear? Two equal charges, capital Q, are placed at a distance D. Two equal charges, capital Q, are placed at a distance D. A small charge, small q, is placed at its center, so the system is in equilibrium. System is equilibrium means net force at that point is zero. Net force is zero. It means electric field is zero. So if it is so, find the relation between Q and Q. Let this is A and this is B and this is point C. This charge are Q, Q and Q. A small q is placed at the center of two charges capital Q, two charges capital Q, then the system is in equilibrium. That is, net electric field intensity at A or B are zero. Let EA vector is equal to, I can put EC vector plus EB vector. This is big H, small, let beta, this is center means this is d by 2 distance, beta q by d by 2 rho square plus beta q by d square is equal to 0. Beta by small d square common, q by 4 whole 1 by 4 plus q is equal to 0. It means q is equal to minus 4q, or q is equal to minus q by 4. Electric field is not here 0. When I place the charge, electric field either at A or at B is 0. Clear? So electric field at A is 0. Electric field at A or B are 0. That is equilibrium. Net force is 0. So EA vector is equal to EC vector plus EB vector. So EC means distance is d by 2. 1 by 4 by epsilon 0 q by r square. Here B means total distance is d beta q by d square. So 4 beta q by 1 by 4 comes to the numerator. So 4q plus q is equal to 0, or I can write q is equal to, if we take it to the right side, minus 4q. So q is equal to minus q by 4. This is the regular questions. Q1, Q2 are placed at a distance d. Find the point along the line joining. Let Q1 and Q2 are placed at a distance apart d. Find the position along the line joining where electrical intensity will be 0. Let that point is any point we have taken, let it be t at a distance x. Clear? So here electric field is 0 mentioned. Find the position along the line joining where the electric field intensity will be 0. Let this is A and this point will be B, and I have taken this point will be P, any point P. If it is so, electric field at P is equal to electric field at A plus electric field at B. Clear? And electric field at P will be 0, it is given. If it is so, EA vector mode is equal to, I can write it as EB vector mode, or beta electric field at A will be Q1 by the distance is x square, or beta into EB. If that distance is x, the remaining distance will be d minus x, Q2 by d minus x whole square. So beta beta cancel out, or I can write d minus x by x whole square is equal to Q2 by Q1, or d minus x by x is equal to plus or minus Q2 by Q1. I have taken both side root. Clear? Both side root. Therefore, d minus x minus 1 is equal to plus or minus Q2 by Q1, or d by 1 plus or minus the position is x is equal to d by 1 plus or minus over Q2 by Q1. Let Q2 is equal to Q1. X is equal to D by 2. It means if two charges are equal, Q2 and Q1 are equal, then Q2 by Q1 is 1. 1 plus 1, 2. Answer will be D. You can ask it, sir, you have mentioned here plus and minus sign. You have mentioned both plus and minus sign. Then plus sign. Plus sign for like charges and minus sign for unlike charges. If the two charges are equal sign, then there will be plus sign. If the two charges are of opposite sign, one is positive and another is negative, then there will be minus sign. Listen to the x must be closer to the smaller charge. Whenever you are going to count the x, the distance, the position must be toward the smaller charge or very closer to the smaller charge. You have to mind it. Let us imagine that Q1 and Q2 is given. If Q1 is 4 microcoulomb and Q2 is 16 microcoulomb. Listen carefully. This is 4, this is 16. Both are same sign. Then are placed at 9 meter. Then x is equal to d by 1 plus root over Q2 by Q1, or I can write 9 by 1 plus 16 by 4, that is 9 by 3 is equal to 3 meter. Clear? This is about today's class, electric field. In the next class, we will discuss about the electric field lines and in detail about the remaining part of the electric field. Thanks for watching. Thanks to one and all. All the best. Bye.